Okay, I'm going to test what's coming out of the rotovertor into the run cap phase, also called the rotary transformer phase. We're going to see how many volts there is and how many amps are circulating. And kind of want to identify where is the run cap phase, what is it for everyone watching. So this test is the AC input, which is going to be the 60 hertz 120 volt grid from here in Seattle. It's going to go through an ammeter to L1. L2 is the other side of the AC input. L2 shares one side of the cap, run cap. L3 goes to the other side. So, right now I have an 8 UF cap right here. And I'm going to start it up with only an 8 UF cap, and we'll see what the amps is running the rotovertor motor. So, here we go. I'm going to plug it into the grid. 1, 2, 3. Hear it going. Take the lid off. There it is. The amps input is 0.33. It's running on an 8 UF cap. Now I'm going to change the cap value of the run cap to, say, 5. First of all, here it is without any run cap. 0.18. That's no run cap at all. Let's try a 5. Here's a 5. That's how you tune a rotovertor, is you try different run caps. So it went all the way down to 0.09, 90 milliamps with a 5 UF cap. I'm just going to go with a 1 UF cap here, because when I did scoping it, this had a nice sine wave and a phase shift to it. Okay, we got a 1 UF cap hooked up. Went up to 1.14, I don't know. Let's just go with this. Okay, now I want to see what the voltage is across this cap and what the current is. So wait 1 minute. Okay, I have a 4 UF cap as the run cap now. This is the voltage. Oops. And across the run cap now, it's 171 volts AC. Okay. Now measuring current. This is circulating current. There's no load except for the cap. Current is is 250 milliamps of current going to this 4 UF run cap. So let's try a 5 UF run cap. Five UF cap gives almost 300 milliamps of current circulating, and the voltage wow, what's going on? 178 volts across the run cap. So this is not watts, this is volts, amps, reactive, VARs. This is what's circulating through that run cap phase. So this is what you get to play with, is this power. And this is what's within the run cap phase. And you can change what you have. Let's try the 8, just for the fun of it. Let's bring this. Ooh, it's growling now. With the 8 UF run cap, we have 560 milliamps circulating. And 198 volts across the run cap. So when you take out power from the run cap phase, you also want to adjust what the cap is, the run cap. And I did a video before about this when I was in Paris airport. So one way you can take out power is put a series transformer, and that goes to the load. You can use 2 transformers. You want to include caps, like cap here, maybe a cap here, but definitely have the run cap. Everything's going to be changing values when you add a series transformer. See the way the L3 line is broken, but it goes through the transformer on one side. It's called a series transformer. So I'll do another video later, and we'll be testing what the input is in amps versus what we can get out of this transformer into a load. Right now we're just testing the VARs, the volts, amps, reactive they call it, and I call it circulating amps and volts. The best rotovertor I've had 7 times more volts, amps circulating than the volts and amps in watts to the input. So there's something to play with. So just kind of an introduction to the run cap phase. Just for grins the way you start it up is you put a start cap in parallel to the run cap. It'll give it a lot of juice and it'll start from stop. When it gets up to speed, you disconnect the start cap. You want to have this maybe 75 UF. Actually, this motor I have now is so efficient, I only need an 8 UF run cap, start cap, just to get it going from stop. But usually you have like a 50 to 100. And never connect your start cap while it's in latch to the sine wave speed running on the run cap, because it'll cause a whole bunch of magnetic braking. And it's possible to actually explode your motor if it's going really fast and you all of a sudden add the start cap and just, it'll just explode. One guy I know, it leaped off the bench and broke some of his ribs when he put in a start cap while it's in sine wave latch speed. So this is a 4-pole AC induction motor, 3-phase, and it's going 1800 RPM now. It's latched right in with the 60 hertz sine wave. And again, here's how you hook it up. You have your AC input. One side goes to L1 and the other side goes to L2. L2 shares a connection to one side of the run cap, and L3 goes to the other side of the run cap. That's the basic rotovertor circuit diagram, and your rotovertor will be hooked up to the WYE, they call it star also, configuration. And you want to have this in its high voltage circuit. Like you want to hook it up, it'll say on the label 460 volts, that's the way you hook up the motor. And then you run it on only 120, so it makes the draw very low. Okay, I think that's pretty good for now, going step by step. Okay, thanks for watching.